Welcome to Module 1 of our Airline Engineering Supply Chain course. Today, we're laying the foundation, understanding the operational context we work within, and the ecosystem of partners and regulators we rely on. This will give us the strategic lens we need before diving deeper in later modules. Let's begin with the aircraft lifecycle. Every aircraft, from a supply chain perspective, goes through three major phases: entry into service, in-service operations, and retirement. This is when the airline takes delivery of a brand new aircraft. It sounds simple: bring the aircraft in and start flying. But in reality, the engineering supply chain has to do months of work before that first flight. You need to load new part numbers into your inventory systems, procure initial provisioning stock, train staff, acquire specialized ground equipment, and set up manuals. For example, when JetBlue first introduced the Airbus A220, they had to source parts like nose gear steering actuators that weren't interchangeable with any other fleet type. They also had to coordinate with Airbus for technical documentation and software tools. Now the aircraft is flying. This is the bulk of its life, 15 to 25 years typically. Your supply chain supports every maintenance check, every unscheduled repair, and every AOG, aircraft on ground, event. Imagine a 787 lands in Tokyo and needs a brake fan replaced before it's returned to Sydney. You need to know, do we have it in Narita? If not, can we fly it in or borrow from another operator? When an aircraft retires or goes back to a lessor, we enter the teardown or redelivery phase. You might harvest usable parts, sell them to third-party traders, or return leased components with strict conditions. A few years ago, when Norwegian returned several 787s, they faced massive costs because certain parts didn't meet the lessor's airworthiness standards, even though they were perfectly serviceable. Supply chain teams were called in to urgently source traceable replacements. Let's now distinguish the three main functional pillars in airline operations, because, honestly, supply chain doesn't live in a vacuum. Flight operations is what most passengers see. Pilots, dispatch, route planning. Their main concern is aircraft availability and flight readiness. Ground operations handles check-in, baggage, catering, and cleaning. Though honestly, these areas are, well, less relevant to the engineering supply chain unless you're replacing galley carts. Engineering and maintenance, however, is where we live. Our supply chain supports every scheduled and unscheduled maintenance event, makes sure parts are certified, warehouses are audited, and tooling is available. Think of engineering as the mechanic and supply chain as the mechanic's toolbox. Without the right tools and parts, nothing moves. Our first major player, the OEMs, like Airbus, Boeing, Embraer, and ATR. They design the aircraft, certify the parts, and hold the intellectual property. OEMs control access to technical data and restrict repairs to approved vendors. For example, if you need a new 737 MAX elevator servo valve, you may find there's only one source, and it has a 14-week lead time. Here's a case. A mid-sized carrier once had to ground an aircraft for 10 days because the OEM part had no alternate sources and customs clearance was delayed. The cost wasn't just the part, it was the lost revenue, passenger disruptions, and reputational damage. So OEMs actually rely on a network of tiered suppliers. Tier 1 suppliers, well, they deliver complete systems like landing gear from Safran, avionics from Honeywell, or seating from Recaro. Tier 2 suppliers, on the other hand, make sub-assemblies, things like actuators, sensors, and brackets. So, Tier 3 suppliers are the ones who provide raw materials, like castings, forgings, and carbon fiber. Now here's the kicker. We rarely contract directly with Tier 2 or 3. But honestly, delays at that level still hit us. During COVID, for example, one Tier 2 composite resin supplier in Italy shut down, and that ended up halting seat production across Europe. You might get a call from engineering asking why the seat back tray won't arrive on time. And the root cause? It could be a resin plant you've never even heard of. Next up, let's talk about MROs, that's maintenance, repair and overhaul providers. You'll deal with both in-house MROs and third-party MROs. They're the ones who repair rotables like actuators, avionics and valves. The key metrics you'll want to keep in mind: turnaround time or TAT, scrap rate and the ever-frustrating BER, beyond economic repair. Just imagine sending a thrust reverser actuator for repair, expecting a $5,000 quote, and the MRO tells you it's BER and a replacement will be $80,000. Now you're scrambling to source one as soon as possible, and your planning budget is, well, blown. Good supply chains maintain rotable pools, monitor supplier performance closely, and dual source when possible. So let's talk about lessors, who actually own about half of the global fleet. Why does this matter to you? Well, lease return conditions can be honestly pretty brutal. You need OEM parts only, no PMAs, no exceptions. You also need traceability, often full back-to-birth documentation for every component. And everything has to be reconfigured exactly as the lease dictates. For example, I've seen operators rip out beautiful new Recaro seats and reinstall 15-year-old Collins seats just to meet those strict return conditions. This is really where engineering supply chains have to be hyper-disciplined, tracking serial numbers, archiving documents, and maintaining a clean bill of materials for each aircraft. Now, our final player is regulation. You'll be dealing with the FAA in the United States, EASA in Europe, and your local civil aviation authority as well. They control part certification, repair station approval, and all the documentation requirements. Without the right paperwork, like FAA Form 8130 or EASA Form 1, even a perfectly functional part is completely worthless. I once saw a $60,000 radar altimeter get scrapped just because its traceability paperwork was lost during a warehouse system migration. That's exactly why system integrity is so important. Airlines are audited regularly. Auditors check warehouse labeling, humidity levels for rubber parts, shelf life tracking and calibration logs. Your supply chain systems really need to be bulletproof. So to sum up, the airline engineering supply chain operates in a high-stakes, compliance-heavy environment. Unlike automotive or retail, we don't just move parts, we move safety. You need to know your aircraft's lifecycle needs. Understand how flight operations, ground operations, and engineering all interface. Recognize the risks across the supply ecosystem, from OEM bottlenecks to regulatory penalties. And in our next session, we'll zoom into forecasting, demand planning, and inventory strategy for engineering supply chains. Let me leave you with 3 quick reflection questions. What's the most common cause of part delays in your current environment? Have you ever seen a part rejected due to missing documentation? What happened? And what would you do differently, knowing the risks from Tier 2 suppliers or lesser demands?